lecture number 19 for the chapter application of derivative and discussing the miscellaneous exercise, and we will do the question number 9 here. Now it is given that it is a cuboidal pit whose volume is given and the height of this pit is given. You have to find the minimum cost to construct this pit where the cost of preparing the base is given and the cost of making the or plastering the walls is given. So you have to find the minimum cost to make it. Now we know that the volume of the cuboid is length into breadth into height. The volume is given as 8, height is given as 2, and the length and the breadth of this cuboidal pit be x into y. So x into y is equal to 4. Now the area of base is x into y, which is 4. We have already found it out, and the area of 4 walls we know for that twice height, length plus breadth, or you can find the area of the base area of this wall plus area of this wall plus area of the back wall plus area of the front wall. Now the area of this base will comes out to be this is x into 2, then the area of this wall is also x into 2, and the area of the back will be y into 2, and the area front is also y into 2, or you can use the area of 4 walls as twice height, length plus breadth. Twice height means 2 into 2, or length plus breadth, you can do like this. So area of 4 walls will be 4x plus, replacing the value of y as 4 upon x. Now to find the cost as minimum, the cost will be 70 rupees for the cost is given as to prepare the walls at a rate of 45 and the area of base at a rate of 70. Now the area of base is x into y, which is 4, so 4 into 70 plus this is the area of walls, and the cost to making it is 45 per unit, that is 45. Open this bracket and simplify, find its derivative with respect to x, which will be 0, 180, 1 minus 1 upon x square, which is comes out to be 4 upon x square. Put it equal to 0. Find the value of x, that is 2, because x cannot be 0 or less than 0. Find its second derivative, which will be 180 into 0 plus 8 upon x cube. You take your own time to find the derivative of 1 upon x square, which is minus 2 upon x cube. So that is 8 upon x cube, which is positive when x is equal to 2. So the minimum cost is there when x is equal to 2, and the minimum cost will be obtained by putting the value of x as 2 and 2 here. You will get the minimum cost. Why it is minimum? Because you have showed that this second derivative of the cost function is coming out to be positive. So it is given that in this question the cost of making the base and the cost of making the walls is given. Area of the base is length into breadth, and its cost of making is 70 rupees per unit, and the area of walls is 4 twice height, length plus breadth, and its cost of making is 45 rupees. So this is the total cost, and you have to show that its second derivative will be positive to make it cost as minimum cost. And the minimum cost is obtained by putting the value of x in the cost function, which is 280 plus 180 plus x plus 4 upon x. Now in question number 10, it is given that the perimeter of the square and the perimeter of the circle is constant, which is given as k, and you have to show that its area is minimum when the side of the square is equal to the diameter of the circle. This you have to prove in this question. Now it is given that the perimeter of the square plus perimeter of the circle, which is equal to k, it is given. So let the radius of the circle be r and the side of the square be x. Now the perimeter square is 4x plus perimeter of the circle is 2 pi r. So either you find the value of x in terms of r, or you can find the value of r in terms of x. because you have to show that the total area is minimum. So the area is area of the square plus area of the circle. Area of the square is side square, which is x square, and area of the circle is pi r square. Replace the value of x in terms of r, as we have already found it out here, and d upon dr you have to differentiate with respect to r, and you have to show that its second derivative with respect to r will be positive. So differentiate. As usual, the pi r square derivative is 2 pi r. Now the derivative of this, first of all, differentiate the power, which is 2k minus 2 pi r upon 4, multiply by the derivative of this, which is coming out to be minus 2 pi upon 4, that is pi upon 2. Now put it equal to 0, find the value of x, which we will get in terms of k and pi. Take r common in these two, take this to the left hand side, the value of r will be this, that is k upon 2, 4 plus pi. Now find its second derivative. The second derivative you can find for this. Now this is 2 pi and this is 2 pi square upon 4 minus 0, because this is the constant term. So it will be greater than 0 for all values of r. So the area is least when r is equal to k upon 2, 4 plus pi. We have already find it out. Then the side of the square is, what is side of the square? K minus 2 pi r upon 4. Replace the value of r. We have already find it out in terms of k, because you will get the value of radius on the side of the square in terms of k, which is 1 upon 4 k minus 2 pi k upon 4 pi. On simplifying, you will get x is equal to 2r. Open the bracket, cancel out. The value of x will comes out to be 2r. So the area is least when the side of the square is equal to the double of the circle, which you have to prove in this question. K minus 2 pi upon 4, take 1 upon 4 here, put the value of r, multiply and open the bracket, you will get x is equal to 2r, and the maximum terms will be cancelled out. Now in question number 11, it is given that there is a window which is rectangular at the bottom and semicircular at the top. It is given like this: rectangular, semicircular at the top. This is the shape of the window, and its perimeter is given, which is equal to 10. You have to find the dimension of this window when the maximum light can enter through it. Now the maximum light can enter through it only when it's have maximum area. So it means you have to show that its area maximum, and the perimeter of this is given, which is equal to 10. So let the radius of the semicircular portion be r, so its diameter will be 2r. Therefore its length of the rectangular portion will be equal to 2r, and let the breadth or the height of this window be h. So the perimeter is given, which is equal to h plus 2r plus h plus 2 pi r upon 2. Perimeter of the semicircle 2 pi r upon 2, which is pi r. 2 pi r upon 2, which comes out to be pi r. This is 2h, this is 2r, this is 2r. So you have got the relationship between h and r, or find the value of h, which is coming out to be half 10 minus 2r minus pi r. Now the area of this figure will be equal to length into breadth plus area of this semicircle, which is pi r square upon 2. Pi r square upon 2. You have let the radius of this semicircle r, length, the diameter will be 2r, then the length of this rectangular portion will be 2r, and we have let that the breadth of this rectangular portion be h, and you have to show that its area is maximum. So area of this figure will be length of the rectangle, that is 2r into h, and the area of the semicircle will be pi r square upon 2. Now replace the value of h here, which is half 10 minus 2r minus pi r, and be careful in the calculation. Open the bracket, and you have to differentiate it with respect to r, which is coming out to be 10, 4 pi r minus pi r, put it equal to 0, and the value of r is coming out to be 10 upon 4 plus pi. Now the h can be obtained by putting the value of r here as well as here, and when you simplify it, you are getting h is equal to 10 upon 4 plus pi. 4 plus pi. You take your own time to do the calculation. The height of this window is 10 upon 4 plus pi, and the radius of this semicircle portion is 10 upon 4 plus pi. The length of the rectangle can be obtained by 2r, that is the double of this, that is 20 upon 4 plus pi. If you find the second derivative of this function, which is 0 minus 1, 4 plus 5, which is coming out to be negative. So it means the area of this window is maximum when the height is 10 upon 4 pi and the radius of the semicircular portion is 10 upon 4 plus pi, and the length of this rectangular portion is 20 upon 4 plus pi, because the length is double of the radius of the semicircular portion of the window. So this is the question number 11 of this miscellaneous exercise. In question number 12, there is a triangle, and there is a point on this hypotenuse of this triangle, and which is at a distance of A and B from the two sides of this triangle, at a constant distance A and B from the two sides of the triangle, and you have to show that the length of this hypotenuse of this triangle is minimum, and its minimum length is, you have to show that it is equal to a raised to power 2 upon 3 plus b raised to power 2 upon 3 raised to power 3 upon 2. So draw a triangle ABC, take a point A whose distance from the two sides I have taken as A and B. If I let this angle be theta, then this also coming out to be theta, because this is a perpendicular line. So these are parallel, they are the corresponding angle, and the corresponding angle will be equal. So if this point which is a distance of A and B, now in the triangle PMC, we know the perpendicular, you can find PC. So sine theta is equal to A upon PC. Sine theta is equal to A upon PC. So from this we have find the length of PC, which is coming out to be A upon sine theta, that is A cosec theta. Now in triangle A and P, we know the base, so cos theta is equal to base, that is B upon AP. We are trying to find the value of AP and PC in terms of A and theta, so that we can find the hypotenuse of this triangle, which is AP plus PC. So the value of PC is coming out to be A cosec theta, and the value of AP is coming out to be B sec theta. So in this triangle, sine theta is equal to A upon PC. In triangle A and P, cos theta is equal to B upon AP. So the length of PC and AP is B sec theta and A cosec theta. That is AC is AP plus PC, and AP is B sec theta, and PC is A cosec theta. And you have to show that it is minimum, and its minimum length you have to show. And we have let this AC as L. So differentiate L with respect to theta, that is dl upon d theta is coming down to be B sec theta into tan theta, and the derivative of cosec theta is equal to minus cosec into cot theta. Put it equal to 0. Convert into sine and cos. You are getting the value of x tan cube theta is A upon B. And the tan theta is A raised to power 1 upon 3 and B raised to power 1 upon 3. This is the value of tan theta. Find the second derivative of this, which will be somewhat lengthy. You have to use the product rule in this sec theta into tan theta, and the product rule in cosec theta into cot theta, and you can do it easily. Take your own time to find its derivative. Open the bracket. By multiplying this bracket by B, multiplying this bracket by A, it comes out to be B cosec cube theta plus B sec theta tan square theta plus A cosec cube theta plus A cosec theta cot square theta, and it will be positive when tan theta is A raised to power 1 upon 3 plus B raised to power 1 upon 3, because all terms are positive and the value of tan theta is also positive. So its second derivative is also coming out to be positive. So its length, that is L, is minimum when tan theta is A raised to power 1 upon 3, B raised to power 1 upon 3. Now use the trigonometry, because we know that tan theta is perpendicular upon base. Use the trigonometry or Pythagoras theorem to find its hypotenuse of this triangle whose perpendicular base is given, which is under root A square plus B square is coming out to be this. Why we have find it out? Because we have to find the minimum length, and the minimum length is B sec theta plus A cosec theta. And why it is minimum? Because we have shown that the second derivative is coming out to be positive. So why we have done this, drawn the triangle? Because from this tan theta raised to power 1 upon 3, B raised to power 1 upon 3, we are trying to find the value of sec theta and cosec theta. Instead of this triangle, you can use the trigonometric identities to find the value of sec theta and cosec theta from tan theta. That is sec theta is equal to under root 1 plus tan square theta, and from that sec theta you can find the cosec theta. So the minimum length is B sec theta plus A cosec theta. Put the value of sec theta, which is hypotenuse upon base. This is the hypotenuse. This is hypotenuse upon base, and the value of cos theta is equal to hypotenuse upon perpendicular, this upon this and this upon this, cosecant sec theta. There. Take under root a raised to power 2 upon 3, b raised to power 2 upon 3 common. So b upon b raised to power 1 upon 3 and a upon a raised to power 1 upon 3. On division, the power will be subtracted. A b ki power 1 minus 1 upon 3, a ki power 1 minus 1 upon 3, which is coming out to be b raised to power 2 upon 3 and a raised to power 2 upon 3. And the power of this bracket is 1 and the power of this bracket is half. The base is same of these two brackets. When you multiply, their power will be added, that is 1 plus half, which is equal to 3 by 2. So this is the question number 12, which is somewhat lengthy and you have to use many terms to find the minimum length of this triangle. Thank you. We'll discuss the remaining question in the next lecture. Thank you.